the title is Ruby on Robots. Like I said, not a whole lot directly on robots here, but I hope you enjoyed anyways. My name is Andrew Carmer, and I'd like to thank over here Graham and Alyssa for putting this all on again. I know we all really appreciate it. I think there was Zach involved too. Like I said, at the core of this talk, it's not very technical. It's not necessarily about robots. It's more to me about imagination and creativity, and maybe a little bit about growth as well. And what I mean about growth is that like through free and open thought and communication, we can all grow as people and developers. We can grow our society. Through curiosity and exploration, we can all grow. By thinking beyond the realm of the status quo, we can grow our minds, we can grow our world, we can grow possibilities. Code can make our lives better. So anyways, I hope you find some value in this talk. Like I said, I am Andrew Carmer. You can find me on Twitter at AJCarmer or on GitHub at Carmer. This is my first conference. This is actually my first talk at a conference of any kind. Thank you. Hope it goes all right. Last January, all I really knew about Ruby was that I could print hello world in my terminal. So I've been programming now for a little over 7 months. I think it's gone pretty well so far. I'm really excited to be here and be able to talk to you guys. But you might be asking, like, what gives me the authority to talk to you, probably very seasoned professional developers, about a topic today? And I guess it's just Graham right here. Graham and Alyssa said I could. So if you want to bring it up, just talk to them. The whole committee, okay. Yeah, displacement of blame. But really, probably the main reason I'm here is because a friend of mine and a man I've learned quite a bit from, Steve Kinney, helped me put together a really great proposal that was accepted. So big thanks to him. And also a quick shout out and thank you to Turing School of Software and Design, where Steve is an instructor. I wouldn't be here without them. So like I said, we're going to talk a little bit today about automation. If you read the intro, it was kind of more about home automation, lighting. I'm going to sprinkle in a few ideas I have about Internet of Things as well. And that's because I think the future is really all about the Internet of Things technologies out there, about data, and about automation. I think Internet of Things should be about everyday people and everyday problems and the obstacles that we all face. It should be about the solutions to those obstacles. With the technology, we can conquer both mundane and extraordinary problems alike. And the way we conquer any kind of problem is simply by building stuff. And in regards to automation and the Internet of Things, like building stuff, what kind of things can we automate? Before I get into the meat of this talk, we'll just talk a little bit about this. Stuff. Basically anything. Anything that has a sensor can collect data. Anything that you can attach a controller to can act on that data, and we can automate quite a few things. I think roads are a great possibility for automation. Like roads could have sensors that collect data that tell public transportation or our vehicles when there are dangerous conditions or delays or anything like that. So if we build stuff and we connect it to the internet, we can have some pretty extraordinary things. And I know you all know what the internet is, but to me, it's a place we all go every day for a little bit of information. We go there for the news. I go there for radio or any sort of social interaction, news source, any sort of thing. And at the core, really, the internet is this like interconnected global communication network. People can communicate, but things can also communicate. So we talked a little bit about stuff and the internet, and together those things can create smart things, things that are intelligent. And some people may say, like, things being smart, things being intelligent, that's a little wild, it's a little crazy. But if you stick with me, I think I can put it into perspective, at least the way I think about it. And when I think about things being smart and intelligent, I think about them kind of broken down like this: an awareness, reaction, a consciousness, and in turn, intuition. So first, awareness. Really, to me, this is just gathered and stored data. This is where sensors come in. Then we have a reaction, which is just a response to all that gathered and stored data. Next, we have intuition, which is simply a recognition of patterns in historical data that's been gathered and stored. And finally, we get into one of the more abstract thoughts, a consciousness of our things. And this is an aggregate process of a device's awareness, reaction, and intuition. So what kind of things can be smart? Anything. Anything that can have a sensor, anything that can have a controller attached to it, we can write appropriate algorithms and make them smart, make them intelligent, make them respond, and improve our everyday lives. Now, are all those things practical? Definitely not. But are some of them fun? Definitely. As you saw, I skipped to a slide. The Nest is one of these smart things out there right now. I think this is a practical thing. I think most of you would agree with me. Then there's G's Smart Smoker. I think that this is more fun, but maybe a little practical too. This thing has, I think, dozens of sensors that measure everything from smoke velocity to heat. It's pretty cool. We have the Fitbit. That's pretty practical. And then one of my favorites is the June oven. This can sense what is inside of it, adjust the temperature and the cook time to what's appropriate for that item. So this brings us to what we can do. And that's we, as in us here, weekend warrior hardware hackers. And really by building and experimenting with small projects, expanding on those ideas, and creating new things, we can possibly influence what people think, about what people think is possible, and about what people think is accessible to them. We can write code to make our everyday lives better. We can start to do this with the Arduino. And before I get into this piece, I want to give a shout out to a man named Austin Vance. I've never met him directly. I think he was a pivotal guy that wrote the Dino gem, which I'm going to get into here in a minute. A lot of these ideas I heard from him, and I think are pretty cool, so I'm going to present to you guys. So first, what is the Arduino? Wikipedia tells me that the Arduino is an open source computer hardware and software company, project and user community that designs and manufactures controller-based kits for building digital devices and interactive objects that can sense and control the physical world. Basically, the Arduino board is this single process microcontroller, and it's like a small computer that can do one thing. And we have all sorts of different kinds of Arduinos at our disposal. In the top left there, you see the lily pad. We can sew that into clothing. We can automate all sorts of tiny objects with that. The Uno is on the right of that. That's probably our most versatile Arduino. There's the Leonardo, the Micro, and dozens more. So you might be asking, really, like practically, what can we really do with an Arduino? And I think that the possibilities are really endless. There's a lot we can do. What can you imagine? One of the cooler examples I found are self-tying shoes. I found a pumpkin flamethrower out there. Halloween is coming. An autonomous lawnmower. Not that I hate yard work, but this is in my plans. We have bubble machines, yogurt makers, a night lamp, camera accessories, everything from high-speed flash modules to even like motion sensor captures. There's even automated camera sliders, really all sorts of really cool things in this field. So, how do we get started with the Arduino? And that would be with the IDE, or the Integrated Development Environment that it provides us. With the IDE, we can write and compile code onto Arduino. Once we compile that code, it's permanently there until we override it or if we replace it. That means the Arduino is now standalone. It can be used virtually anywhere, and the only downfall, to me anyways, is that you have to write C++ to interact with it. I don't know C. C is hard to me. It's complicated. I don't know anything about memory allocation. I like that Ruby does all that for me, all the garbage collection and all that hard stuff. Luckily, there is hope out there. As I said, this is one of the ideas I got from Austin Vance, using Arduino as a service. We can start thinking about the Arduino more like a service by having it read sensors and interacting with the physical world that way. We'll just talk with the Arduino via computer, really. The problem, though, is if I hook this up to my laptop, it's now not a standalone unit and I'm tethered, which creates a big problem. But luckily, we do have a small, tiny computer, the Raspberry Pi, that can be our friend in this. You can install Ruby on your Raspberry Pi and interact just like you would with your laptop. Now, there is Node.js out there. It's a really great resource. It's asynchronous, just like C, so it's kind of a natural fit for programming hardware with the Arduino. Libraries like Johnny 5 are pretty widely accepted right now. Unfortunately, Ruby is not asynchronous like JavaScript and C, which makes things a little harder. But we're not here to talk about JavaScript, I realize. We're here to talk about Ruby, and my personal favorite programming language. So why automate with Ruby instead of JavaScript, especially if JavaScript is kind of ahead of the game and doing this really well? It's because Ruby is accessible. If we can bootstrap with Ruby, if we bootstrap the automation, it will allow for really quick prototyping. And the main reason is because the reason we use Ruby in the first place. It's desirable because it should be, it allows us to write fast, easy to understand code in a human-readable syntax that can really allow anybody to inherit that code and understand it really quickly. So I've messed with a few gems out there as far as automation goes. There's R2 on the left up there, and as I said, the dino gem, which I will be talking about today. Getting started is pretty easy with the dino gem. Gem install dino. That's about it. If you do that correctly, you should see a little screen that looks something like this, and now we have quite a bit to work with. The first thing, when we dig into the dino gem, we can notice that we have a board class. And this is really the first step interacting with the Arduino. It has pins, it has I/O, it lets us read things and know how to talk to other things. It kind of looks at all the messages coming into it. Then we get the TX/RX class. This is where all the communication happens. It kind of sends and receives messages for the Arduino and really makes the initial handshake and communicates with our board. Then getting into our components a little bit, we have LEDs. All the component classes are really straightforward in the dino gem. There are only maybe a couple dozen lines, so you can dig in and understand exactly what's happening. The LED class simply has an on and an off method. Then we get servos, tiny motors that get about 180 degrees of rotation. We have a position and an angle method within this class. There are also stepper motors involved, included in this gem. Stepper motors are a little more complex than servos in that they can make full rotations, counterclockwise or clockwise, and those are actually the two methods we get with stepper class, is a counterclockwise method and a clockwise method. And then we get our sensors, which has a data receive method and a data update method. There are a few more components, but those are the main ones that we have. It's really all that simple. It's not too complex if you'd like to start digging in. We can actually now take a look at how we can start setting up our Arduinos. You'll find a lot of fritzing diagrams out there if you're looking for a project to mimic. I am not an electrical engineer either, nor do I write C, so I like to find something to kind of get me started. This is a simple fritzing diagram for hooking up an LED, and a blinking LED is kind of like the hello world of automation of hardware. So now, after you've set up some of your hardware, we can select what type of Arduino we're using from the IED, or from the Arduino software. We then simply create a sketch, as it were. We type this command into our terminal, which gives us a DU directory in whatever directory we type this command. In that directory will be a .ino file, and that is what we will compile onto our Arduino. So now to a couple examples. I think I'm running on about 5 minutes, so I'm going to go through what I'm going to tell you what I'm going to talk about, and then I'm just going to switch over and show you guys. I'm going to show you a quick hello world. Then we're going to talk about a couple servos. Like I said, they're just a little motor that gives you about 180 degrees rotation, but you can be pretty exact with that. if anybody out there was able to attend one of the sessions yesterday, I think Tom Leskin and Eric Dowdy put on a lesson with servos and the Arduinos. I heard it was pretty good. Finally, I will show you a quick little sprinkler head demo I've got set up that should show us a simple example of how to interact with the Arduino and the servos. All right. So here we have our first example, like I said, the hello world of hardware is a blinking LED, and I think a simple blink is a little boring, so I decided to write a little Morse code hash so I could type a message for y'all and have it blink said message. So you enter a message here. Hello Boulder, Rocky Mountain Ruby 2000, it's 15, isn't it? Time warp. I simply sanitize that with downcase so it matches my hash and split it into characters so I can iterate through each of the Morse code loop and then print, tell my LED by sending it the on or the off method. This first condition just allows for spaces. So we send the on or the off method and then sleep for a second to have a gap in our words, and I'm also putting our character to the screen. So, I'll put that up top so we can all see. We have Ruby Morse code. Oh, you're getting cut off here, aren't you? (2015). So, thanks, guys. So as you can see, it takes minimal Ruby. It's really straightforward. It's really easy to get started prototyping very simple things, and by stringing this all together, we can make some pretty complex stuff, which I think is pretty cool. Next, I will show y'all my servo sprinkler example. In this, I have, as you can see on the screen right back here, I have 3 servos. And they are like mock sprinkler heads. There's no water going to be squirting in the crowd or anything. I've got 3 sprinkler heads set up. You instantiate the board through the dino gem, pass through it the communication center, the TXRX class. We set up a servo from our Arduino components. We specify exactly what pin in the Arduino they are hooked into, and also pass through the board. So like I said, I have 3 servos, one in pin 13, one in pin 11, one in pin 9. And then this little simple piece of code here is telling it to cycle through these angles. I go about every 10 degrees, and then from 180 back to 0 in what I call the sprinkler motion. So, should see, oh, actually, forgot I need to switch these. All right, now we should see that. I think I froze my computer. Oh, there we go. All right. Some water in the lawn. Thanks, guys. What I think is really cool about playing with this in Ruby is we can actually, with our little friend binding pry, start to kind of like really zero in on the algorithms we want to use if we're getting more complex things. As you can see here, the terminal, Oh, I see you. Thank you. Is that good? About like that? Cool. Is that good for everybody? Cool. All right, so like I said, we've got a prize session in. You can see that we've required dino, we've instantiated our board and our servo, and now we have access to our servo, and we can tell it what position to go to. Oh, I guess you want to see this, don't you? Can everybody see that? All right. So if I tell it to go to 180 degrees, it'll go to 180 degrees. If I tell it I actually just want it to go to 50 degrees, you can tell it that. We can play around and get very precise with it to create an algorithm to do a more complex task. And that's what servos are really about. Stringing together complex tasks, maybe with other simple machines like gears and levers, to give us something bigger and better. So, with that, I leave you. I appreciate you guys' time. Thank you very much. Again, I'm Andrew Carmer. You can find me on Twitter and GitHub.